Hello and welcome to Disseminate the Computer Science Research Podcast. As usual, I'm your host, Jack Wardby. Today, it's my pleasure to say that I'm joined by Rui Liu, who will be telling us everything we need to know about his paper towards resource-adaptive query execution in cloud-native databases. Rui recently received his PhD in computer science from the University of Chicago. Before we do start, another quick few announcements. Remember, if you do enjoy the show, please consider supporting us through Buy Me a Coffee. And we do have a listener survey out at the moment, so please go and check that out. Anyway, on to today's show. Welcome, Rui.
Hi, Jax. Thank you so much for having me. I'm really excited to be here.
Fantastic. Let's get started then. So I like to start off with my guests and getting them to tell us their story. So maybe you can tell us more about yourself and how you became interested in research and databases.
Yeah, sure. So for myself, like you just mentioned, I recently received my PhD degree in computer science from University of Chicago, where I was co-advised by Professor Aaron Imo and Mike Franklin. I also work very closely with Professor Sanjay Krishna. So my PhD research is about building resource-efficient data-intensive systems. So during my PhD, I was also a research intern at Grid Systems Lab of Microsoft, a data science intern at the AI engineering team of DocuSign, and a visiting student at Arbitration. But the question about my research path, towards the data management research is like, if you take a peek at my resume or my CV, you probably will see a very diverse or zigzag background. So unlike many of my peers, I didn't get a chance to do some database research when I was an undergraduate student. My research path is started by my undergraduate final year project, which is about mobile computing. The professor who advised me on that project, taught me some very basic research methodologies. And then after that, when I graduated, a lot of my classmates become a software engineer, and I feel like probably I want to do some research rather than being, make some contribution or impact in the industrial. So then I decided to purchase a master degree, and then I finally find the Hong Kong Polytechnic University would be one who accept me as a MPhil student. That's I think that's a research oriented and fully funded master scholarship. It's like you can consider it as a mini version PhD. We still took several classes, but we spent a lot of time on doing research, and we got salary every month, and then we need to defend our thesis at the end of this master so that we can get degree. And but still at that time, so my research focus remained on the mobile computing, but I do, I did begin to explore some areas like ubiquitous computing and cyber physical systems. I also, once I finished that, I also got a chance to join a systems security group at the Chinese University of Hong Kong, because that host was my co-authors for 6 months, basically. The next was a research citizenship. And during that time, I still got a chance to explore some privacy and security projects or whatever. But so far, you can tell I do have some experience on, different areas. They're pretty diverse, But one thing that has not changed is I have to manage a lot of data, that including user information, sensing data from sensors or mobile devices, and some location or timestamp data. So there's a lot of them. So you need to efficiently manage them, you need to compute them, get whatever you want. Those challenges of data management fascinated me. Yeah, probably that's the cool thing if we can, explore some research ideas in that area. And then I found this whole data management area. And almost at the same time, I decided to go to US for a PhD degree. So I said, why don't I just combine them together, get a PhD in database area? That's pretty good, right? But the one issue I'm facing at that time is pretty difficult to get in, get accepted by a decent PhD program if you cannot show some solid research experience and the skills, right? Then I managed to go to the National University of Singapore to join their database research group, working with the Professor Ben Ching Wei. I think at that time I did explore some database or data system research, like blockchain, memory management, data cleaning, something. There's pretty a lot of projects in that group, and I think I did a good job. And eventually, he wrote me a recommendation letter, and so that I can get into the University of Chicago. And from that time, I started my data management research path. So I think that's my whole story. I'm probably a little wordy, but yeah, that's a long path.
No, that's awesome, Rui. Yeah, I mean, there's a few things kind of what you're saying there that sort of like resonated with me as well. Sort of not taking the linear path to databases and a PhD in databases is something that sort of happened with me as well. I mean, I started out doing mathematics and economics as my undergraduate. I had this dream of being the next Wolf of Wall Street, and then slowly transitioned away into statistics. And you can kind of see how kind of computers came in a little bit more computational statistics, and then finally settled on a PhD in databases. But one thing I will say that I think, I don't know if this is true with you, that it sounds like you've been through a lot of different areas and got exposure to a lot of different areas of computer science and various different topics. Do you think that served you well for your PhD, that exposure and having that broad understanding of the wider area rather than being sort of laser focused on one specific topic for such a long time?
Yeah, I think so. Exposing to different area and then finally focus on one makes me have a stronger motivation to be here. So like, because I already know what others area looks like, and then finally I choose this area because I want to. And I do use some other previous experience on other areas to do my research.
Yeah, you kind of have that kind of cross pollination of ideas and stuff, and you
Right,
never know
yeah,
when something that you've learned 5 years ago might all of a sudden come back to you, and you might think, oh god damn, that's brilliant. I remember this, and I can apply that to this, and yeah, I can see how that
exactly.
works.
Yeah, exactly. Yeah, it's feel of me.
Yeah, cool. So let's talk about the paper that you published at CIDA recently, and it's called "Towards Resource Adaptive Query Execution in Cloud Native Databases." So there's a few things in that title there, some background we need to set up here, so the listener can kind of get on board with what we're going to be talking about for the next hour or so. So let's kind of start things off with, tell us what a cloud native database is.
Sure. Yeah. I mean, there's a lot of definition of the cloud native database if you Google it. But my definition is like, so cloud native databases are designed to export the benefit of cloud computing environments. So unlike the traditional databases that are often deployed on specific hardware or within fixed environments, the cloud native databases are built from scratch for cloud environments. Some key features or advantages of them are like scalability, multi-tenancy, high availability, and pay-as-you-go pricing model, and the automatic databases maintenance. You name it, there's a lot of different things. Some example of cloud-native databases are like Amazon Ratchet, so Google Spanner, and Microsoft Cosmos DB. There's a lot of other products in the world. But I think those databases are optimized for performance, availability, scalability in the cloud, and making them very, very powerful for a lot of range of applications like web or mobile applications and some microservices or IoT systems, or even the machine learning and the current trained large language models.
Yeah, nice. It's a really nice definition of cloud native databases. I mean, yeah, you see, you go on Google and you stick that in, and there's like 1,000 different definitions of it, right? And it's kind of hard to feel, okay, well, this person's saying this thing, this person saying this thing. No,
Yeah,
that's a really nice definition of cloud native databases. So we're in this world then, and everything's sort of shifting towards this and using these all the primitives that these cloud environments give us. What are some of the kind of the key factors then that we need to think about that make us have to reconsider the architecture for the way we would develop a system in a cloud environment? I guess, yeah, kind of what I'm hitting at here is give us the kind of the elevator pitch for this paper, really.
Yeah, sure. So I think that's a very interesting question. So I think one observation we have is like we argue that the ephemeral cloud resources are becoming prevalent, because their prices are really, really attractive compared with the traditional on-premise or on-demand, the cloud resources. So there was a report I remember. So they said the peak time price of the regular cloud resources are like 200 times higher than the ephemeral cloud resources. So there's a huge difference here. But there are two, unique traits of these ephemeral cloud resources. It's like the ephemeral cloud resources are pretty dynamic in availability. Even the cloud resources provider may get them back for some reason. So that means the resources usage can be terminated. Second is like even their prices are very attractive, but usually the price are fluctuating over time. So that their peak time price will be much higher than their off peak time price. And this fluctuation is the fluctuation time period is not like days or weeks. It could be hours. So that's really, really dynamic. So based on these two observations, we feel like it's time to propose a new or reimagine what the cloud native databases looks like. So this is just not pictures. I can give you some concrete examples. Like, so if you Google like Amazon Spot instance, you can Amazon provides some short-lived but really, really good deal cloud resources for you. So if you just want to use like 1 hour, 2 hours, probably you can find a very good deals here. And also there's another cloud paradigm called zero carbon cloud. It's proposed by pretty good or famous Professor Andrew Chen in University of Chicago. It's like in this zero carbon cloud paradigm, the entire data center are driven by the renewable energies like wind, solar, like, there's no cost for that. It's pretty good, right? So but the problem is like, we cannot control wind, we cannot control weather. So the resources sometimes, or the energy sometimes will be terminated. So you can see, once you imagine those applications or the big pictures we have is, you want to consider, what if the resources is not stable? How should we still use them to build our system or build our cloud native databases? So this paper shows our vision of the best practice for building and deploying these cloud native databases on ephemeral cloud resources, especially from the perspective of cloud service provider.
Nice, yeah. There's some interesting things there that we was talking about, the sort of the fluctuation over time of these spot prices, and that it can be in the magnitude of hours for it to change. I mean, that's kind of crazy, right? So, but anyway, and I also really like the sound of these carbon, like zero carbon data centers, which is
zero carbon cloud,
zero carbon cloud. So it's a fascinating thing. And anyway, cool. Let's talk about I guess these primitives that you've proposed then, that we need to basically be aware of when we're building a cloud native database on such an environment. So yeah, tell us about these primitives you've identified in your vision.
Yeah, so I think we provide 3 primitives in this paper. One is called the query preemption. I think that's describe the ability of permitting the queries to consistently consume. So once we have very limited resources, like we know the resources will be terminated, it's very dynamic, and it's not reasonable to keep allocating resources to some long running queries. So some other short running queries have to wait until the long running query is finished. That will significantly increase the latency of the query, right? So for those cases, I think the one important primitive we have is that we should allow the queries can be suspended, adaptively paused when there's a need or there's a beneficial to do so. I think that's the primitive one, the query preemption. But that's for single queries, or once we have one query, right? The second primitives we have is called resources arbitration. Let's move to the scenario like we have, multi-users. There's a multi-tenant environment of a workload. Viewing the same assumption is like the ephemeral resources, fluctuated in availability and the cost, how much resources a query needs. That's an answer already answered by the existing resource reservation or scheduling mechanism, right? The question we want to ask is like, is it worth allocating resources to a particular query or job? This is because we have a limited resources, but we have a large amount of workloads. How should we allocate the resources to them? The thing make this worth or more important is like, once we look at those query, the progress curve of each query, it's like they increase at the very beginning significantly or quickly, because probably a lot of the data processing jobs are iterative. We process data batch by batch, right? The first batch may already give you very rough idea of your final result, but your final batch just push your final result like from 90% accuracy to 91% accuracy, right? So you can imagine, you combine everything together, we have limited resources, we have larger workload, and each workload, they can get their results pretty good at the very beginning batch, but they will get, they will waste in a way their resources at the final batch. How should we, allocate it? Well, those things, once we put everything together, we have this primitive 2, the result arbitration. The third primitive, we call it cost tolerance. It's about pricing model. Like I mentioned before, so right now it's state of art pricing model is pay as you go. So how much resources you use, how much money you pay, right? Then in our vision is like, if we allow service provider or the users allow the service provider to suspend their job, for some reason, and then I can give you more fine-grained pricing control, or there's more options you can choose. Then, some users may take it, because not everyone is care about low latency, high availability, something like that. So I think for those users who prioritize cost efficiency over speed, then they may prefer more options. Like, even if you suspend a job, and then I'm totally fine as long as you give me a good deal.
Yeah, awesome. So just to repeat those back to you then. So the first one is our query preemption then, Rui. So that's basically saying that we can adaptively, giving users of cloud environments the ability to adaptively pause and suspend their queries. Then we move on to our resource arbitration, and that is where we kind of want to ask the question: is it worth allocating something to a job? Because, like you said, in the case of iterative queries, there's this sort of diminishing return of sort of not all iterations are equal.
Right. Yeah.
Earlier ones are more valuable, and then they are, because, like you said, going from 98% to 99%.
Yeah. Sometimes you want to give resources to the more promising jobs, right? Sometimes you want to keep allocating resources to one job until this job pushes the limited back, really far from the current state. So it really depends your goal, your objective. But
it's all about having that flexibility, right? That's the thing. Kind of having a more sort of flexible then this kind of comes into the pricing model, right? And the cost tolerance, and just exposing more options to users. That is better for the users in terms of like cost, right? They maybe don't spend money, or then they would need to. And it also, I guess, frees up resources for the cloud provider to then sell to somebody else, right? So basically, everybody wins, right? That's the sort of the goal there.
Exactly.
Right? Better pricing model.
Yeah.
All boats rise. So awesome. We've got our 3 primitives then, and then to sort of realize these primitives, you've developed a framework called Ratchet. And tell us more about Ratchet. Give us the high level overview of how you put these primitives into practice, shall we say?
Yeah, definitely. Yeah. By the way, you have a better summary than me. I think that's
so you just told you literally. I'm just repeating back to you what you've just told me. So it's fine. Yeah.
Yeah. So for Ratchet, essentially, it's a novel, or it's a new resource adaptive query execution framework. So like you said, to realize these 3 primitives. So it's a framework. So we can have a different way to implement it, right? But in our paper, we propose 3 components, or like 3 pillars in this framework. One is like we designed an adaptive query execution framework, which enables the query suspension and resumption at using different strategies. Second component is like a resources arbitration mechanism. It's responsible for determining resource allocation for query suspension and the resumption during runtime. The third one is like a cost model, like provide user more fine-grained set of the resource cloud resource utilization and price options. So I think overall that's the framework, Ratchet.
Nice. That's the high level overview. So let's dig into one of these one by one. Let's do a little bit of a deep dive then. So kick us off with the first pillar, then the adaptive query execution framework. You mentioned there's a few different strategies there, and how we're going to go about suspending these jobs and things. So yeah, give us a bit of a rundown of how that works.
Sure, definitely. So yeah, before we get to that question, is one thing I want to announce is like, the paper described this first primitive just got accepted by the ICDE 2024. And then if any audience want to look at more details, you can find it. But probably it's not public right now because we didn't put it on website. But I believe it will be published very soon, so you can find it. And let's go back to that question. So for the primitive 1, the active query suspension and resumption framework. So in that paper, we have this framework, and this framework consisting of different query suspension and resumption strategies. Those strategies are, at different levels. So for example, we can see the most naive one is called the redo query. So once your resources has been terminated, you don't do anything. So your query will stop there, and then once we want to resume it, we will rerun it. That's the most naive one. Another strategy is called we call it operator level suspension strategy. So it's actually original from a previous work called query suspend and resume. I think that's a work proposed by Patrice from the Macros Research. That's a pretty big name here. And then another strategy is we call it this pipeline level suspension strategy. So that's something we developed for Merkle-driven or pipeline-driven query execution. Those things is like, unlike operator level suspension, they suspend the query at the operator which has the lowest memory usage, because so that we don't really need to persist too much data when we suspend the query. Pipeline level strategy is like the pipeline level query execution is like they split the query pipeline into different pipelines. And then our strategy or our method is like we can suspend this query once a pipeline is finished. And then all the intermediate data of this pipeline will be persisted. And once we want to resume this query, then we can rebuild this query pipeline and then get those persisted intermediate data of all the processed pipeline, and then going from there. Some other strategies has been proposed in this framework is like we call the data batches level suspension strategy. It's like we don't care about the query execution part, but we split we can split the input data into different batches, and we can suspend the query once one or multiple batches are finished. And then it's pretty easy to keep the progress and the intermediate data, right? And there's another strategy that we also developed. It's called we call the process level suspension strategy. It's like we consider, so we don't care about what happened within the databases. We suspend the whole process where the database application is. So that means if the database has multiple processes to handle multiple queries, and once we want to suspend one of them, we suspend the entire process. And then we keep everything within this process into disk. Yeah. And then once we want to resume it, we resume the process first and reload everything within this process and then process it from there. Those things is, you can see in this framework, we have very, very diverse or different strategies, but there are some trade-offs between them. It's like you can imagine once we want to redo a query, there's no cost here. It's like we just let it stop, and then we do not persist anything, right? And then once we resume, we rerun it. But the thing is like we lost all the progress. There's nothing here. But for the process level suspension strategy, it's like we keep everything. So we suspend once we know the results will be terminated, we suspend the query and we keep everything. But the downside is like the intermediate data or the state could be really, really large, because we are not only keep the databases data, so we keep the process data, almost everything. So I think the question is like, how should we select the most appropriate one once we have different queries, we have different user requirements, we have different environment. So that's something we want to answer. That's the primitive one.
Sorry, a quick question on that real quick. Is that sort of the flexibility? It's a very it's a very flexible sort of framework there, the different levels from all the way down to redo, that you can lose everything, but obviously then there's no preservation of state, so there's very low overheads in that respect. Is that something that, maybe we'll cover this later on, I'm not quite sure, but is that something you want to surface to the user of these systems so they can actually declare, like, what does the user interface look like? Can I say, yeah, my query is a redo query. It's a data batch level sort of computation. Like, how do I express that as a user? Or is the system intelligent? Can the system work it out, or is it something that's surfaced to the user?
Right. Yeah. So this, again, so like I mentioned earlier, is like, so those systems are from service provider perspective.
Okay,
so
right.
So that means the system will make a decision, but they will consider user requirement. For example, like I said, so if I tell you that the users really, really want to get their data faster or fastest, or in a really quick way. I don't really care money and I spend all my money on that. Yeah, and then I won't even suspend your query. I will try my best to carry run until the end.
Right.
But if the user says, okay, I don't really care, how much suspension you could afford, we will give them fine grained. In our vision, we will give them fine grained options like 1 or 2 or 3 or what different or other way to let user indicate their expectation. Based on all these things, our system make decision which suspension strategies could be used.
Gotcha. So there's a mapping there between sort of the high level, what the user does, and then that gets converted down into these different sort of strategies you use. Cool. So I guess with that, we're on to pillar number 2 now. So yeah, take it away.
Cool. Yeah. So pillar number 2 is the resource arbitration. We already have a paper about that. But for that, it's like once we have multiple queries, the multi-tenants, we consider like user have very diverse requirements. So we define like competition criteria. It's like user will say, when I think our query can be finished, or when I think the result will be acceptable, right? So like accuracy will be like 90%, or I already scan like more than 90% data or whatever. So our system will estimate how much progress a query can achieve if I give you a specific amount of resources. So we will estimate that thing, and then we will do like some bandit style process. Like we see if we allocated those resources to these jobs, we estimate how much progress you have, and then we probably will. It depends on different goals. If our goal is try to keep the resources to the most promising ones, I will give the resources to the job who can achieve the most progress. If I really care about like fairness, I don't really want one job fall behind. I want to, everyone can achieve some, reasonable progress. I probably will keep allocating resources to the one achieve latest progress. So this framework this primitive 2 give us the ability to adaptively allocating resources to different jobs and to achieve some, greater good, like fairness or efficiency, right? So yeah, that's the primitive 2.
So on that primitive 2, sorry, really quick.
Yeah, sure.
So what fairness for one job is maybe not the same fairness as the fairness for the other job. I mean, I'm thinking here because fairness is not really necessarily a well-defined thing, right? Or it's very ambiguous. It can depend on your perspective, and that can be applied, I guess, to the same thing to jobs to query execution, right? So, is there a global setting there, or is that pillar adaptive? So, like, it can be like the fairness is almost query level, and that's then used to come up with a global sort of decision that's fair, I guess, with respect to everyone's preferences. I'm sorry if that doesn't make much sense, but yeah.
No, it's done. So I think that's a good question. So essentially, we support both of them. It's like, if we know, for example, so it depends on workload, and like I said, we support both of them. So, for example, if all this workload are from the same user, what they want to do is like we want to find it. So they just random give so different configurations to different data processing jobs or machine learning jobs, whatever. I want to find the best one. I want to find the best result. Then this overall workload may have the one global objective. I want to find the best one, right? But if this query is from different users, like they may have different requirements, different goals. Like there's make no sense if we set a global objective for them, right? Because everyone is individual. So in that case, we will consider like, what's your objective? What's your competition criteria? How much money you want to spend? And then we can, adapt this like by the way to allocating limited resources to these jobs and to try to keep everything happy.
Yeah, cool. I guess, yeah. So then number 3, the cost model. So tell us about pillar 3.
Right. Yeah, the cost model is like, this is a vision as well. We haven't published any, long paper about that. But in our paper, the vision is like I mentioned, we try to provide some like see as you pay pricing model rather than the pay as you go service model. It's like if like I mentioned or already emphasized multiple times, if you allow me to suspend your query or you give me some tolerance you can have, then I probably give you better choice or better prices options, and then you will be happy. I will be happy because I can reallocate the resources which should be allocated to you to some others to make more money, and then everyone's happy. And I think in that case we somehow achieve a better utilizations for these limited resources in terms of money, or in terms of how much money the service provider make. So I guess in that case, cost tolerance is like fine-grained pricing model, and what we call is like suspend as we pay model.
I guess that sort of kind of brings the vision sort of together. We've kind of got our sort of three pillars there, each component. So with this obviously been a vision paper, there's a nice section in your paper about the future directions for Ratchet. So tell us a little bit about where we go from this then. So we've got this framework. What's the next steps?
Yeah. So I think since I just graduated, so I want to make another attachment is like about our U Chicago group. It's like, so this project is a long-term project. It's under the supervision of the Professor Arimo. There's a bunch of talented people doing this. Our next step is like, actually we already start making a suspension-oriented database system. It's like we consider the queries, the suspension is the first class citizen for this database. Okay. We think that the query can be suspended or should be suspended. And then in that case, what the modern database is like, how should we redesign each component to support that requirement? In that case, there's a very important difference. Like we cannot assume the query can run from beginning to the end. And then once we have multiple of them, what we suspended of them, you can imagine some challenging issues like how should we keep the consistency? How should we keep the isolations? Or once we have multiple versions, what if the data changed when we suspend the query and when we resume the query? How should we guarantee that the result will be the same? Or which one you want? Probably user want, like when we suspend the query, the data is like the old version, and once they resume that, the data could be the newer version. How should we do that? Which one do we want? So this some, I think, promising research direction. And also you can imagine like this system is not only good for like resource limited, but it's also provide enough flexibility to almost every system. It's like if we want to, so if the cloud instruction need to upgrade regularly, or under maintenance, the system need to shut down or for some time. Without this suspend-oriented databases, everyone lose their progress, or we need to find a way to do that. But right now, as long as you can, you tell me when you want to shut down the infrastructure or upgrade the upsize or downsize your resources scale, I can find a way myself to keep everything happy, right? Yeah. So you can imagine there's a lot of way or application cases we can use those suspension-oriented databases. And also another thing is like, I think we want to spend some time on spend more time on this Peter series. I think it's not only about databases research or content science research. They may need some, economic thing, like how should we provide comprehensive pricing models, like give user more options, and then we can have a different mechanism to handle each options, and then make more money. So basically, I think that's probably the future work of the near future. For the 10 years or 20 years, I really have no idea.
Okay, so we're at base camp at the moment for the research group's sort of next sort of agenda for the next 10 years, and we'll see where it goes. But it sounds like there's plenty of interesting directions for it to be going in for sure. So the listeners,
thanks.
Should keep a lookout for the papers coming out of your group, because I'm sure they'll be very interesting. The question that I like to ask some of my guests sometimes about the work is, if you put your reviewer hat on for a moment and you kind of ask the limitations of your work. Obviously, this is a very like vision, so it's kind of hard to know the concrete limitations of the work at the moment. But
right,
I guess what limitations, or what challenges do you see in taking this vision and actually making something realistic and concrete and practical out of it? What are the big challenges you think, or the limitations that you may hit into in the long term, or even in the short term?
Yeah, I think we could have some discussions or brainstorms when we explore this area or this project. But I think several things we discussed before is like, well, actually we make some assumption here. It's like we know we somehow know when the termination will happen, right? If termination happened suddenly, like next second, and we have no idea, there's no way to handle those progress, right? So that means one limitation or several cases, one case that we cannot handle is like the termination is unexpected. No one tell us, then we probably will, lose everything, or we will behave very, very bad. Yeah, that's one thing. But if you can give us some hint about when the termination could happen, I saw it could be not necessarily be a exact time point. You can give us a range, an interval. The termination could happen within this time, like 5 minutes or 30 minutes or whatever. Then we
sometime on Tuesday. Yeah.
yeah, exactly. Yeah, we can find a way. So I just want to give us some hint. We will try our best to develop a system, to keep everything in a good shape.
Nice.
I think that's the one thing we haven't decided yet. Second thing, I think probably will change this project significantly. Is like, what if we will have a really, really good world in the future? The resources are not limited. Even the zero carbon cloud infrastructure somehow, based on very, very good people or engineer, they somehow managed to get this energy really stable. Even it's driven by the sustainable resources source, the energy source. They can somehow get those resources stable. There's no need to consider the resources will be terminated. I wish they could, and I really want to live in the world like that. We have unlimited resources.
Yeah, it sounds a bit sort of utopia, this glorious future that will probably never happen, right? But it sounds great.
Right,
yeah. I don't know how
but
realistic it is.
But in that case, if in that case, well, our project probably won't play a significant role there, because we have two assumptions. One is like resources are limited. We consider this will be the trend. Consider the global situation here. So like, everything. And then we consider we will have some hint about termination. As long as you can give us these two assumptions, and then our system or our project will give you good answers.
Nice, cool. So yeah, I guess we kind of spoke about the vision there a little bit, and I guess, I mean, what impact do you think Ratchet can have longer term as well? Do you think it can be, how revolutionary do you think this project can be? Kind of I guess going forward. I mean, and how do you think it could affect there's kind of two questions here. Sorry. So there's the general impacts of the project.
No, that's fine.
And then there's the impact on the day-to-day of software engineers and data engineers. Yeah, if we're putting our prophecy hat on now, and we're going to say, okay, this is what's going to happen in the future. Like, what impact do you think it can have?
The findings or the impact of Ratchet, we think it's like, I think I already emphasized this a lot of times, is that we want to argue that we should try our best to use the ephemeral cloud resources. We should even to accept the termination, to consider termination is a regular thing rather than stable is a regular thing. Like, so we once we consider resources will be very dynamic, can be terminated sometimes or somehow, then how should we design a system to handle them or even utilize them? But I think that's the biggest the argument or findings in our research that we want to consider. So I think for software engineer or the data engineer, my guess is like once they run or they develop a system, they never consider, there's the resources can be terminated or there's no. I don't think they consider that the resources will be a problem. They will consider how should I maximize the resource utilization, but they won't consider like, what if I have sometimes if I have no resources, what will happen? Yeah, I think that's linked to some existing area like fault tolerance, recovery mechanism, or checkpointing. You name it. There's some existing topic in that area, but with our research, we provide another way to reconsider those things. What if can we just try to keep as much as progress or keep the necessary progress and makes people think, okay, that's good enough for us if the termination could happen. I think that's something different from the previous research work.
Yeah, I guess because it's kind of when you were talking about the in the first pillar in the framework and the different strategies, kind of as you were talking about those, I was thinking checkpointing. I was thinking those sorts of things, and that's kind of what was coming at like save point and whatnot. But then I guess what's happening here is this has now been surfaced as an interface basically that people can kind of interact with, rather than it being like hidden within the system within the database somewhere it's doing checkpoint. Now we're kind of actually being able to exploit it and use it in our applications and whatever. So yeah, no, I can definitely see the parallels and how you are basically using those and putting them in a different light.
Right.
Yeah.
Yes, exactly.
So the next one that I like to ask a lot is, what's the most interesting thing you've learned while working on the project? So in this case, on Ratchet, what's been the best insight you've kind of got from it? Most surprising, maybe?
I think the most interesting lessons I learned from that is like, so I think let's link to some backstory or original story of this project. It's like, so this project is actually come from the original one. So previous project I had is like as I mentioned, that's the rotary, like we want to schedule different jobs during runtime, and then we want to give them the most appropriate resources. And then we found during runtime, so we want to preempt those queries. We want to, during runtime, we want to, reschedule the resources, and we need to suspend them. And at that time, we use the checkpoint method that support not only support not only the processing job but also the machine job. So anyway, we rely on the checkpoint mechanism to suspend job. And sometimes we find checkpoint will be a time-consuming process. It may generate a lot of data, and then if we keep doing that, sometimes it will give us unexpected long latency. And that time, so I keep going deeper and deeper and deeper to find those. Okay, how they checkpoint the query process. At that time, we use Spark structural streaming as the platform, and I go inside their source code to see how they checkpoint the thing. And we figure out yeah, they did do some pretty good work, but they definitely there's a lot of process to maintain this checkpoint. So at that time, I think we want to keep exploring, like, can we have a better way to do that? If we could, so what can we, is there any other method we can use to suspend it? So I think that's I think most interesting thing, like if the current project actually is the previous project, some failure point of the previous project. If you keep going, and you will find, okay, sometimes I can make more work on this failure point and then the failure point, and then I can publish a new paper. I think that's a pretty interesting lesson I learned. It's like, first is never overlook any field points. Second is like keep going and find some details. Probably you get something.
Yeah, keep iterating, right? And you never know. Like, keep going, try new things. Yeah, awesome. That's really cool. And whilst we've got you here, Rui, like, it'd be nice for us all to hear about the other work from your PhD as well. So maybe you can give the listener a quick breakdown of some of the other things you've worked on across your studies and your
sure,
research.
Definitely. Yeah. So besides those, I think the research I just described my main research, but I also have strong interest in the machine learning area. So I do some project intersection between the databases and machine learning. So one is like when I was a research intern at Microsoft, I optimized the feature store, and then optimize one. I think is one of the most important operation in features is called point in time join. It's essentially an operator to generate different features, and we optimize them to make it more faster to get this the features for training. And also once I was in the DocuSign AI engineering team, I optimized their container-based hyperparameter optimization workload. So you can consider once we have, I'm not sure if you are familiar with hyperparameter optimizations, but essentially it's like I have a lot of hyperparameter configurations. I want to find the best one get better training results. And then in that infrastructure, they are using the container to run each hyperparameter configuration. Yeah, I optimize it, try to put different container together and into try to train them or execute them in parallel, so to save more time and achieve better results utilization. I also I think it's one of my early work of my PhD study is like I explore how once we have multiple models, and is it possible to combine or pack them together as a bigger one and put them in a single GPU and train them simultaneously, so that we won't need to without hurting the final result of each model. I think those some other research I explore or I did during my PhD study, but I think I will keep doing some of this machine learning work.
Cool. Well, if any of those topics sounded interesting to the listener, we'll put links to those in the show notes as well, so you can go and follow up and have a look at some of the other awesome work that Rui's done. So I've just got there's 2 more questions for you now, Rui, and
Sure.
the first one you maybe touched on a little bit a second ago, actually, when you was talking about iterating and kind of following through with ideas and kind of not kind of giving up with them that easily, sort of thing. But it's all about your creative process and how you approach research and how you approach idea generation. And then once you've got an idea or a set of ideas, selecting which ones to dedicate time to and to pursue. So yeah, how do you go about that? What's your process?
Right. Yeah. So I think first thing first is like as a PhD student, you cannot ignore the role of your advisors. So
This
your
is very true.
advisors, yeah, it's very common. They carry a lot of weight once we want to get the ideas or cycling project. But for myself, I think I consider ideas as 2 kinds of things. Like one is original idea, the other one is optimization idea. So for original idea, it's like you create something never exist. It's really totally new. But those original ideas, they need inspirations, patience, other workings. That's something is really difficult to measure and follow, right? But I do, according to my experience, like I think I have some experience on the optimization ideas. Like something probably others have followed. It's like first find the area you have interest in, and then you keep exploring, and you will find some project, find some paper, you find some important contributions, and then the thing I would like to find is their assumption, their scenario, their applications, and then I will see, can I break one or multiple assumptions of them? That may give us totally different thing, right? Is the application or environment has been changed since the paper or the project proposed? Like for example, a couple of years ago, there's no GPU, there's no very powerful hardware, there's no NVMe or you name it, and now we have all of them. So can we use those new things to change some existing work? And then of course I want to see, is there anything missing? Is there any chance I can optimize or I can add more function to overall improve the existing works? That's something I usually will do once I want to propose an optimization idea, try to improve the existing works. So that's my idea generation. And for the project selecting, I think I'm a little bit pragmatic. It's like so once we select project, is of course interest is one thing, but we need to consider the deliverable results, like how much money, how many times do you have, what's the result you are expecting. It's like, do you want to have a paper in 3 months, do you want to have a paper in 1 year, or do you want to have a long-term project and at the end of your PhD journey and you can announce like, everyone, I make a really, really cool thing, everyone should look at. What's your goal? And so sometimes once I figure out, okay, this is something I want to achieve, and then I will see, okay, what's the best way or what's the best project I can achieve that goal. So I think, yeah, that's my way to select project. But ideally, definitely, it will be much better if I can select a project I really love. But
Yeah.
that's usually not the case.
Yeah, that's for sure. But no, I liked what you were saying about you with just going back to the idea generation part of your answer there, and sort of like understanding all the variables, all of the assumptions, and then thinking, how can I change these variables? How can I break this assumption and let you see what happens and follow those? That was a really nice part of that question. And yeah, it's always good if you have something that you're passionate about, right? It makes it so much easier to work on something and pursue something if you are passionate about it and you're really interested in it. So yeah, no, that's a
Right, yeah.
really nice answer to that question, Rui. Cool. So we're at the end now, so it's the time for the last word. And yeah, like, what's the one thing you want the listener to take away from this podcast episode today?
I think, yeah, I want to say, I consider the competing resources or energy based resources are more rare compared with, the time before. Yeah, and you can imagine how the modern data processing job, you know, how complicated the modern data processing job are, and then how large the large language models are. And then you can see, they are resources consumption job, right? The tasks. So in that case, I think we need to consider if there any better way to, fully utilize the resources, even the resources are not stable, even the resources are, ephemeral, then we really want to use them because, yeah, the resources are rare in the future. So, and each of them will you can imagine a lot of current model computation job consume a lot of resources. So I think that's the thing. Yeah, I think that's one way to keep to let audience think is there any other way or is there a better way to have a better system? I think that's one message I want to deliver.
Great stuff. Good message to end on for sure. So thank you so much, Rui. It's been an absolute pleasure to talk to you today. If the listener wants to find any of Rui's work, we'll put links to everything in the show notes. So you can go and check those out. Whereabouts can we find you on social media, Rui? Are you on any of the platforms, LinkedIn, Twitter? I'm sorry, X, should I say now? Can we find you anywhere?
I have a LinkedIn account. I think people can find me on that platform. For others, I'm not very active social, media guy. So I
Sure.
guess probably, yeah.
Email maybe might be the best way to contact you then if they want to talk about the work that we've been speaking about today, I guess. So we can put your email in there, something like that, so you can get
Yeah,
loads
probably.
of
Or
emails
you
now.
can, yeah, or you can send me a message on LinkedIn. I guess that's another way to reach out to me.
Fantastic stuff. Yeah, and a reminder again that if you enjoy the show, please consider supporting us through Buy Me a Coffee, and we'll see you all next time for some more awesome computer science research.